Hi guys, I miss you. Hopefully you guys are doing good. I wanted to share with you guys on adding and subtracting radicals. So we've been simplifying, but now we're going to add and subtract. So the first thing though that we need to do is to practice our simplifying skills. So we're going to simplify everything in the problem first. So if I'm looking at number 1 here, my first step is going to be to simplify. I'm going to go ahead and make my tree here. So 45 is 9 and 5. 9 is 3 and 3. 9's gone, so I'm going to cross that one out. So I see that I'm looking for, I have an index here of 2. So I'm looking for groups of 2. So I have a group of 2 here. That 3 is going to go out to meet the 2. And the 5 is going to stay inside. So I'd have 2 from the beginning here. And then I have multiplying that times 3 would be here. And then left over inside would be 5. So in this case, I would have 6 square root 5. And then in this case, the 5 and the 1, they don't break down at all. So it would just be, I'm just going to bring down this whole thing, 2 square root 5. Like that. So that's the first step. The first step is to simplify. The second step is to combine like terms. It says find radicals with the same index and the same radicand. So what that means is that if we're going to find like terms, our like terms, remember, is like if we have 2x plus 3x, then we can add them to make 5x. Basically what we're saying here is if we have 2 square root 5 plus 3 square root 5, then what we can do is we can add the 2 and the 3, and we can make it 5 square root 5. The same way that we had x's, right? Like we don't change the x here. Same thing, we don't change the square root of 5 here. We just add the outsides together. We can only do that if they have the same index, same radical. So in this case, I can see that I have 6 square root 5s and I'm subtracting 2 square root 5s. So I'm going to go ahead and say, okay, 6. If I have 6 of them and I take away 2, then I would have 4 of them left over. So this would be 4, and I leave the radical the same. So 4 root 5, or 4 square root 5. And that would be my answer. Okay. Step 3, it says if they're like terms, add and subtract the coefficients and keep the common radical. So the radical will stay the same. So that's what we did here for step 3. So we're going to do exactly the same thing. This one has 3 parts here. So the first step, if you remember, is to simplify all the radicals. So I'm going to start by simplifying. So go back to my orange. 12 can break into, I'll choose 3 and 4 in this case. And then 3 is good. 4 breaks into 2 and 2 goes away. I see this is radical 2 because there's nothing there. So I need 2 here. It's going to go out and meet that. So I have negative 3 times 2 would be negative 6. And square root 3, that's the leftover one that's going in there. 3 doesn't break down, so I would just have plus 3 square root 3. And then I would have here 20 is 4 and 5. This is 2 and 2. 4 is gone. We need groups of 2, so the 2's are coming out to meet here. So 3 times 2 would be 6, and the 5 is left over. So I have root 5, and that is a positive sign, so I'm going to put a plus sign right there. So now I need to decide which of these are like terms. So I'm going to look at the radicals. So I see square root of 3. Wow, that's hard to see. Square root of 3 and square root of 3. But this one's square root of 5. So that one I cannot add together. So I'm going to add the negative 6 plus 3 would be negative 3. Radical stays the same, so root 3. And then I can't do anything with this one, so I'm just going to add 3 through 6 square root 5. And that's going to be my answer. What we've basically done here is like negative 6, let me see if I can line this up actually. Negative 6x plus 3x plus 6y, right? So like which of those things are the same? I would say this one and this one have the same variable and the same exponent, so we can put these together, but we cannot put those together, so we just have to leave it on the outside. So that's just another example. Don't get confused by that. Cool. And then the last example is here. We can see that we have the higher order roots in this example, so we're going to do the exact same thing. First step again is to simplify, and then the second step is to combine like terms. So first step is to simplify. 48 breaks into, I'll choose 6 and 8 this time. Could have used 24 and 2, could use 12 and 4, whatever, doesn't matter. 3 and 2, this breaks into 4 and 2, both of those have been used up. 4 and 4 break into 2 and 2, 4's been used up. So in order to do this, I need a group of 4 because there's a radical 4, and I can see that there are 4 2's. That means that 2 is going to come to the outside, and I'm going to be left with a 4th root of the 3 is left over, so the 3 stays inside. I can't break 3 into anything, so I'm just going to bring this one down. 2 4th root of 3 plus, and then breaking down 72, do 2 and 36, which I can make 6 and 6, which can be 3 and 2, and 3 and 2, breaking those up. So in this case, I see I have an index of 3, so I need a group of 3 things. So 1, 2, 3 2's, so that 2 can come to the outside. And then the 3 and the 3 are left on the inside. I want to count for both of those, so I still have 3 times 3 on the inside. So I'm going to say, okay, that's 3, square root of 3 times 3 is 9. So move my face out of the way here. You would have 2 cube root of 3. So when we are thinking about like terms, we can only call them like terms if they have the same radical and the same radicand. So the same index number right here and the same number inside. So since those are exactly the same, that means that we can do something with them. So I'd say, okay, 2 minus 2. Oh, well, 2 minus 2 is 0. So those are going to cross each other out. And then I just have this one left over. So my answer would be 2 cube root of 9. And that's my answer.